Okay, so now we're going to talk about solving a compound inequality. So for these examples, we're going to solve and graph the solution set on a number line, write the solution in set builder notation and interval notation. So when we look at a compound inequality written as we see in A and B, that is the same thing as an and compound inequality. We're going to talk about what that means when we start looking at absolute value inequalities in a few minutes. So we can look at this kind of as two different inequalities, but we have three different parts. So we have -3 is less than 2x plus 1, which is less than or equal to 3. So we're going to break this apart. We want to get the x by itself on the inside. So if we subtract 1 from the middle, we're also going to subtract 1 from the left and the right. So -3 minus 1 is -4, which is less than 2x, which is less than or equal to 3 minus 1 is 2. Then to get x by itself, we're going to divide by 2 in the center, which means we're going to divide by 2 on the left and divide by 2 on the right. So now we have -4 divided by 2 is -2, which is less than x, which is less than or equal to 2 divided by 2 is 1. I'm going to go ahead and write this in set builder notation. Remember, that's when we have our set brace with an x, our vertical line, which means such that, and then we're going to close our set brace at the end. Okay, and I'm going to graph. Okay, and our solution was -2 is less than x, which is less than or equal to 1. So since we have a less than symbol, that's going to be a parenthesis. And then 1 is going to have a bracket because of the equal to sign. And we're going to shade everything in between. So now if we match that to make our interval notation, we're going to have a parenthesis, -2, comma, 1 with a bracket. All right, looking at B, we have -6 is less than or equal to 1/2 x minus 4 is less than -3. So I'm going to ignore the fraction for right now, and we're just going to add 4. Okay, so -6 plus 4 is -2, which is less than or equal to 1/2 x, which is less than -3 plus 4 is 1. Now to get rid of that 1/2 x, I'm going to multiply by 2. Then those are going to cancel. And so what we do on the inside, we also do on both the left and the right. 2 times -2 is -4, which is less than or equal to x, which is less than 1 times 2 is 2. So I'm going to go ahead and rewrite that so it's in our set brace. We're going to go ahead and graph it. Okay, at -4, we're going to have a bracket because of the equal to sign. At 2, we're going to have a parenthesis, and we're going to shade everything in between. So now our interval notation is going to match that. So we're going to have bracket -4 going up to 2 with a parenthesis. All right, so that's our and compound inequality. So we also have an or compound inequality, which we're going to look at with absolute value inequalities. So if u is an algebraic expression and c is a positive number, the solutions of the absolute value of u is less than c are numbers that satisfy -c is less than u, which is less than c. Okay, so this is our and compound inequality. And then the second one, the solutions of the absolute value of u are greater than c, are the numbers that satisfy u is less than -c or u is greater than -c. Okay. Here's the easiest way to remember it. Greater than. So greater is the same thing as more. And more sounds like or. Okay. Okay, so again, these rules are completely valid if we have less than or equal to or greater than or equal to. It's going to be the same. So looking at this first one, solve and graph the solution set on a number line, write the set builder notation and the interval notation. So we have 7 is less than the absolute value of 5 minus 2x. I'm going to start off with rewriting that. So we have the absolute value of 5 minus 2x is greater than 7. So I just rewrote it and flipped the inequality. So now we have greater than, which tells us we're going to be looking at or. So we're going to rewrite this. 5 minus 2x is greater than 7, or, and then remember absolute value, we have two equations. So now we're going to have 5 minus 2x. We're going to make it a negative 7, and we're going to flip the inequality sign. Okay. And then solve just like we did with absolute value equations. So we're going to subtract 5 from both sides. So negative 2x is greater than 7 minus 5 is 2. And then if we divide both sides by negative 2, remember when we divide by a negative, we need to flip our inequality. So this becomes x is less than negative 1. Or we're going to do the same operation, so subtract 5. So negative 2x is less than negative 12. Divide by negative 2. Just remember that means we're going to flip. So x is greater than 6. Okay, so for our set builder notation, oh, that was really bad. It's better. Okay, so x such that, and you're going to literally write that same thing. X is less than negative 1, or x is greater than 6. Okay. If we graph this, okay, so x is less than negative 1. That's going to give us a parenthesis, and we're facing the left. I'm going to shade in that arrow. Remember, the arrow represents negative infinity. And the x is greater than 6. So we're going to use a parenthesis and shade to the right, going towards positive infinity. Okay, so now if we want to write our interval notation, we're going to have negative infinity to negative 1, parenthesis. And then to combine it, we're going to use a capital U without the tail. That means union. 6 to positive infinity. Okay. All right. And looking at B, we have negative 2 times the absolute value of 3x plus 5 plus 7 is greater than or equal to negative 13. So the first thing we need to do is get the absolute value by itself. So we're going to subtract 7. So negative 2 times the absolute value of 3x plus 5 is greater than or equal to negative 20. We're going to divide by negative 2 to get the absolute value by itself. So the absolute value of 3x plus 5, we divided by a negative, so we need to flip our inequality, is less than or equal to positive 10. And now since we have less than, this means we're going to have an and compound inequality. So this is going to look like the first two examples we did on this page. So when we break this apart, we're going to take the negative and put it in front, keep our same inequality sign, so less than or equal to, and then bring down the rest. 3x plus 5 is less than or equal to positive 10. Okay, so now we want to simplify the inside. So to get x by itself, we're going to subtract 5. So negative 15 is less than or equal to 3x, which is less than or equal to 5. And then we're going to divide both sides, or all sides, by 3. So we get -5 is less than or equal to x, which is less than or equal to 5/3. Okay. We can change this into our set builder notation very easily. And then if we want to graph it, and I'm going to kind of flip this on its side. I'm going to alternate here just so I have enough room. Let's put 4 in there. Okay. So -5, we're going to have a bracket because of the less than or equal to. And since we're looking at we're looking at everything in between. So 5/3, 3 goes into 5 once with a remainder of 2. So that's going to be 1 2/3. All right, and then we're going to shade everything in between. And then our interval notation is going to match with -5, 5/3, both with brackets. All right, and last problem. Acme Car Rental Agency charges $4 a day plus 15 cents per mile, whereas Interstate Rental Agency charges $20 a day and 5 cents per mile. How many miles must be driven to make the daily cost of an Acme rental a better deal than an Interstate rental? So we're comparing Acme and Interstate. To be the better deal, that means it's going to be less than. Okay. So we're looking at Acme. We have $4 a day plus 15 cents per mile. So 4 plus the 15 cents for every mile is less than Interstate rental, which is $20 a day plus 5 cents per mile. So now if we want to solve, I'm going to move our m to the left-hand side. So we're left with 4 plus 15 cents minus 5 cents is 10 cents, which is less than 20. Then we're going to subtract 4 from both sides. So 0.10 m is less than 20 minus 4 is 16. If we divide both sides by that 0.1, m is less than 160. Okay, so how many miles must be driven to make the daily cost of an Acme rental a better deal? Would be anything less than 160 miles.